right, these are the notes I promised you about tangents after the opening video. Hope you enjoyed that. But in any event, the objective for the day is going to be able to identify and use properties of tangents. So again, we kind of introduced this concept before you left. We talked about tangents. A tangent line is a line that intersects a circle at exactly one point. And the point where it does intersect is called the point of tangency. A line that intersects a circle in 2 points, we're going to be calling that a secant line. We're going to come back to that, but we're going to focus on the tangent right now. What a secant line would look like is if you had a circle and a line that hits it twice, that creates a secant line. We'll come back to that, but today we're going to focus in on this, the tangent line. All right, a couple theorems about tangents. It says if a line is drawn tangent to a circle and the radius is drawn to the point of tangency, then the tangent line and the radius, again, this is what Joey was kind of illustrating, they are always going to be perpendicular. So again, tangent and a radius make a right angle, tangent and a radius make a right angle. There's going to be purposes for that, or usefulness of this, once we get towards the applications. So another theorem that we're going to look at about tangents is when you have two tangents. So if you have two tangents to the same point outside the circle and they're tangent to the same circle, those segments are going to be congruent to one another. So again, that would be this distance from here to here is congruent from this distance from here to here. So over here, same concept. Again, these are applications of these two theorems. So the one theorem is the tangent and the radius are perpendicular. The other one is two tangents to the same circle are going to be congruent. So these are the typical applications of these. The first one deals with the tangent and radius relationship. Tangent segments and radii create right angles, which means you're going to have right triangles are going to be formed. So again, here's my radius, here's the tangent line. For the purposes of this unit, again, if the line looks tangent, you can assume that it is tangent. But here I have the radius is 5, this distance from this point to this point is 12. I'm looking for the distance from the center to this point outside the circle, and that turns out to be the hypotenuse of a right triangle. So again, I could use leg squared plus leg squared is equal to the hypotenuse squared. So if I solve that for y, it's what, 25 plus 144, and that's going to be what, 169. Square root of that is 13. So 5, 12, 13, Pythagorean triple. Down here, now I want to figure out the radius. I know this hypotenuse is going to be 3 root 5. This leg is 3, and that is leg is 3, or x. So I do x squared plus 3 squared is going to equal 3 root 5 squared. So then I'm going to get x squared plus 9. So this would be what? 3 squared is 9 times 5 is 45. So then I would do x squared is then going to subtract out the 9 from that. So that's what, 36? So that means that is going to be equal to 6. So that's an application of the tangent and the radius forming that right angle, forming right triangles. You could use Pythagorean theorem. The other application deals with two tangents outside the circle. You can have this is a circumscribed polygon around the circle. This would be an inscribed polygon. So this just goes over those two terms. A triangle is circumscribed. About the circle, and the circle is inscribed. So that's for this picture over here. For this picture over here, now the quadrilateral is inscribed, and the circle is circumscribed. So that's just getting you used to those two terms. All right, example problems of how I'm going to grade you on this. So here I have a circle, it's circle O. I have these two tangents from the same exterior point M. It says find the value of x. For this unit, you may assume the segments that appear tangent are tangent. So I'm assuming that those are tangent. So this is a radius and a tangent. So remember, these make a right angle. This is a radius and a tangent, so that makes this a right angle. So now I have 1, 2, 3, 4 sides. And I know that if I do 4 minus 2 times 360, or times 180, sorry, that equals 360 degrees. So the four angles of a polygon or quadrilateral should add up to 360 degrees. So for this problem, I would have what? X plus 90 plus 90 plus 117 should equal 360 degrees. So then what I can do is I can do, this is X plus 180 plus 117. Should have got my calculator. So 117 plus 180. That's 297 equals 360. So then I subtract out 297 from 360 and I end up with 63. So that angle is going to be 63 degrees. So that's using the tangent and radius relationship. Over here, again, this is the two tangents to the same circle. You're using that theorem on this problem. So again, these are all exterior points. So I'll work one at a time. So if I use A as the exterior point, again, if this distance from A to D is 10, so AF would also have to be 10. If I'm at B and this distance 15, that means this distance would be 15. And then if this distance is 8, this would have to be 8. So again, it wants to know what the perimeter of triangle ABC is. So now after I found all those, to find the perimeter, I would just add all these up. So that's what, 23 on this side. This side over here is 18. This side over here is 25. So the perimeter on this would equal 18 plus 23 plus 25. So 18 plus 23 plus 25. And that's 66. So that's the perimeter of the triangle. And that's in centimeters. Then the hardest part of these is the pulley problems. I kind of showed you these before. The trick to these, again, is you're going to have a radius on each of these circles, and it's perpendicular to this common tangent, this 35 inches. So this represents a pulley system. Find the distance between the centers. So let's know how far this center is from this center, which is represented by this line right here. So to do this problem, it wants me to go around to the nearest 10. I've got to remember that. All right, so the way I taught you this is, again, this common tangent is going to remain perpendicular to these radii. So if I can slide this, if I start to slide that 35-inch tangent, it's going to slide and then it's eventually going to stop when it hits this center over here. So the 35 basically translates, we learned that last unit, down to this spot, and you're at 35. Now the right angle is important. Again, that radius and the tangent are always perpendicular. Well, these are the radius and the tangent, so that remains perpendicular. So now you can see your right triangle. This is a common mistake to put the right angle at the center, which is never going to happen. It's always between the tangent and the radius. So now that remains 35 inches. I slid a total of 8 inches down this radius, which means I ran 8 inches down this 14, which means there's still 6 inches left over. So now this distance that I'm looking for is going to be the hypotenuse of that right triangle. So again, I would do leg squared plus leg squared equals I don't know squared. So again, go to your calculator, and that would be what? 35 times 35. And then plus 36. And then I got to do the square root of that. So square root. And that's 35.5 if I round it to the nearest tenth. So that's using those two properties. Again, one property is that a radius and a tangent always make a right angle. And then the other one is you have exterior points. Two tangents to the same circle are always going to be congruent. This is in inches. I forgot the units. All right, so what I have left on here is example problems. So you can see these problems right here using those two tangents. Here you have a couple pulley problems here and here. It talks about inscribe, circumscribe, find the perimeter. Answers to which are all down here. I have the completed notes also in the folder. So if you wanted to see how to do that, or you could come to the office hours to see how to do some of these problems as well. I have homework, just a couple problems for you guys to work on. And then if you could scan those in and send those in, and I'll see how you guys are doing. I'll give you 2 points for that. But that is tangents of circles and a couple of theorems about them. So again, if you have any questions, email me, come to my office hours, and I can show you more on how to do these. Thank you very much.